جلسة عندي اليوم بالعشرة.
في الجلسة اللي بعد شوي اللي هي أونلاين. ايوه نحاول ممكن من اللي علق؟ أنت اللي علق؟ مفترض عند المدير نشرح له الملفات هذا وخلاص. يلا هي ظبطنا. شوف هذه هي باقي الدكتور عضو مدري عندك لها ملف شيء. قدرت معي اليوم الثاني الجلسة الأولى اللي كانت وفي واحدة منها أونلاين وهذه الثانية كلهم موجودين إلا الدكتور عضو. في الجلسة الأولى، لا الثاني. هذه كلها سجلنا ظهور مسجلين، يحيى مسجلين، هذا الوضع مسجلين. هذه اللي يرسل على الواتس صح؟ أبو هبة؟ ما هي موجودة. إي والله. من نعطي خبرنا دكتورنا يدير هالشيء اسمه الحين. فيه ينقصنا ملك.
السلام عليكم ورحمة الله وبركاته. المحاضرة الأولى ستكون للأستاذ الدكتور انتصار فخري الرملي. الدكتور انتصار حاصل على شهادة البكالوريوس بالفيزياء من الجامعة المستنصرية في بغداد عام 79، وثم حصل بمرتبة الشرف. الأول كان على كلية العلوم بالجامعة المستنصرية، ثم حصل على شهادة الماجستير في Lasers and Their Applications في تطبيقات الليزر وتطبيقاته من جامعة أسكس عام 1981. ثم أخذ الدكتوراه في Optical Communication من قسم الإلكترونيكس في أيضا جامعة أسكس، وثم أصبح أستاذ في عدد من الجامعات الأوروبية والعربية، وعمل أستاذ في الجامعة المستنصرية ببغداد والجامعة التكنولوجية ببغداد، وأيضا قام بتأسيس عدد من شركات الاي تي، شركات الانفورميشن تكنولوجي في بريطانيا وفي كندا، وقد حصل على جوائز عديدة في كل من بريطانيا وكندا، وأيضا حصل على براءة اختراع، أكثر من براءة اختراع. إحدى براءة الاختراع اللي هي American Patent في عام 2000. فالدكتور انتصار يعني filed full USA patent للريموت داتا ستورج مانجمنت، وبعدين هذه يعني which was later sold. استفادت من هذه الباتنت شركة نوكيا والريسيرش ان موشن، وايضا الدروب بوكس. ايضا نشر العديد من البيبرز، البحوث، في مؤتمرات الاس بي اي اللي هو International Society for Photo Optical Instrumentation Engineers، مقره في واشنطن، والمؤتمرات اللي شارك بها كانت تعقد في لوس أنجلس أو سان دييغو. أيضا الدكتور انتصار له العديد من المساهمات في عدد من الجامعات كتدريسي وكباحث، ويرأس شركة كوميونيكيشن وانفورميشن تكنولوجي في مدينة فانكوفر حاليا. أيضا له كولابوريشن مع جامعة الملك عبد العزيز. فالدكتور انتصار ساهم أحد المساهمين الفاعلين في تأسيس مجموعة أبحاث يسموها ريسيرش جروب في الأندر ووتر كوميونيكيشن، وربطها في الماشين ليرنينج والارتفيشال انتليجنس. في هذا اليوم راح يتكلم للأسف أعتذر عن التأخير، لأنه صارت تكنيكال فيلير أو ما قدر يعطي المحاضرة، فرح عندنا فيديو يعرض لنا الفيديو المحاضرة، وهي أيضا في الاتصالات تحت الماء. يعني اتصالات تحت الماء تقنية جديدة، وهذه تنسجم وتتوافق مع رؤية 2030 في أن المملكة تدخل في توجهات علمية تعتبر من الفرونتيرز اوف ساينس اند تكنولوجي. وهذا موضوع الاتصالات تحت الماء بالليزر موضوع ساخن، يعتبر من الهوت توبكس، والبحوث الأولية حققت نجاحات رائعة ونشر وفي مجلات راقية جدا. فالآن نستمع إلى محاضرة الدكتور انتصار. شكرا.
بسم الله الرحمن الرحيم، والصلاة والسلام على النبي الكريم وعلى آله وصحبه أجمعين. السلام عليكم. Today I'm presenting our research titled Analytical Observation Notes on Underwater Optical Communication Channel Modeling Strategies. In this research, we are categorizing and appraising or assessing various mathematical frameworks for underwater propagation channel models for optical communication systems. The evaluation of these models in this study is based on the scope of the impairments that influence the received optical signal in terms of its temporal profile and spatial profile distribution, and this eventually will help us to assess the receiver performance and help us in designing an optimum design. The model evaluation main objectives is to identify its strengths and weaknesses, and in that way, once we know these gaps, this will help us to find a new foundation to propose a new underwater optical communication model formulation approach. The topics that or the content in this paper covers, first, the underwater optical communication system layout and underwater optical communication optical channel model strategies. We present the strategies here, and we will have 4 strategies. And section 4, we will go through a brief discussion and conclusion, and we will show how we can conclude a new approach for underwater optical communication channel model. Here, we are not deriving the new channel, but we are describing the new approach. In order to understand the rest of the section of this paper, we need to understand the layout of the optical communication system under consideration. The optical communication system consists of transmitter, channel, propagation channel, which means water, and we have 4 types of water, either deep ocean pure sea water, clear ocean water, coastal ocean water, or turbine harbor water. And once we receive the signal, the receiver will process the signal. But this receiver for the underwater optical communication system has an optical unit. And in our view, this optical unit could play an important role in smoothing the disturbance for the spatial profile of the signal, and again, as well, the spatial, not only spatial profile of the signal, but the temporal profile of the signal. After that, the signal goes through a photodetector, and the photodetector has a preamplifier, preamplifier. Then it goes to a filter, and the output of the filter will have a decision unit. So, generally speaking, the noise structure for the transmitter unit and for the receiver unit are very well documented. And we have no issue in describing these noises, but we have a huge challenge in describing the impulse response for the propagation channel, water propagation channel. And in order to understand the model and to understand the derivation of the optimum threshold and optimum units for the receiver, optical receiver, we need to recognize there are three distinct timelines. They are the same timelines. First one is along the transmitter, which consists of the symbols, boundary of the symbols here. And during the transmission, of course, we'll have a bit sequence within a symbol. So the information is here. So these are the boundaries of the power. And after the photodetector, the whole thing will boil down to one line, and the decision unit has a pre-knowledge about the boundaries of the bits, and it make a decision which bit has been transmitted. So this actually diagram represents a memory system, not binary. If it is binary, only will have 2 bits here. This is for PPM, pulse position modulation. But if you have 1 bit within a symbol, and that symbol either 0 or 1, this means that modulation format will be on and off keying. It is very important that we realize that this equation, which represents the first order moment for the data, first order moment for the energy within a data stream of symbols. So within each symbol, there is an average energy here. In order to understand the interaction between the units which makes the system, we need to realize the following: that the signal here, once the pulse leaves the transmitter, the signal is optical. Then it goes through the water medium. And once we receive it here, before the optical unit, at the front of the optical receiver, the description of the signal, which is an optical signal in this case, is actually a convolution of this with the impulse response of the medium. And this is what we are talking about here. There are models which describe this impulse response function. Here, what I have done, instead of writing I of t, I wrote it in terms of the pulse shape multiplied by the maximum amplitude. And here, I sub tau just to give an indication that the shape changes based on the location of the bit within a symbol. Here, the signal is still optical after the optical unit. Here, what we are assuming? We are assuming that the optical unit could play an important role in smoothing the distortion for the spatial profile and the temporal profile of the signal. In all the derivation for the channel models, no one accounted for this eventuality or this possibility. Once the signal goes through photodetector, it will be converted to electronic signal. To describe the electronic signal, here we have this, which represents actually the impulse response of the amplifier, detector, amplifier, pre-amplifier, amplifier unit, plus a thermal noise. But you might wonder, what happened to the optical signal? Actually, this function, this term, is controlled by the capital N. Capital N is the number of the photoelectrons. And this photoelectrons controlled by this wavefront. And this wavefront, this is the background intensity plus the received optical signal. Here I put R sub C, assuming that the impulse response of the optical unit is delta, which means this RO will equal RC. If we wanted to include this, we can just put here a convolution and add this one. Another thing we need to realize the importance of the determining the value of the channel impulse response. The decision unit must know beforehand the formula which help computing the effect of the propagation channel. So here, this unit need that information. Here we calculate the impulse response of the channel and noise estimation. And in this way, the decision unit will make a decision about whether this is 0 or 1. Another element the decision unit need to know in order to do this computation, and that one is the optimum decision threshold. In order to account the optimum decision threshold, if you remember, this is the average of the energy within bits of a symbol equals the signal minus the decision threshold. So in order to make sure this equation holds all the time, we assume that this minus this here as minimum as possible, hopefully 0. In order to achieve that, we need to compute the minimum of mean square error criteria. Once we do that, we will come up with the conclusion, or we come up with the computing the optimum threshold. So in this way, the decision unit will be fully equipped to make decision whether we are having 0